Okay, assalamu alaikum wa rahmatullahi wa barakatuh. My dear students, so in the last class we finished the concentration and strength of acids, and I hope that you understood it quite well. What is the difference between the concentration and strength of acids? In the previous video which I uploaded, I started explaining you the preparation of acids, that what are the different chemical methods, processes by which acids are prepared. The first method which I explained in the previous video was synthesis. By synthesis means combination of two entities. So you can see that when hydrogen and chlorine, hydrogen and bromine, hydrogen and sulfur combines, they form acids. Now in this video I am going to explain you the next method in the list, that is water plus non-metallic water plus non-metallic or acidic oxides. Water plus non-metallic or acidic oxides. Non-metallic oxides are acidic oxides. Okay. Acidic oxide plus water will give you acid. This is the formula which you have to keep in mind, which you have to remember for learning the reactions easily. Because if you know this formula and you know how to balance the equations, it becomes very easy for memorizing, for learning the chemical reaction. So what is the formula? The basic structure is acidic oxide plus water will give us acid. So let us take an example to understand this concept. Let us take the acidic oxide SO3 sulfur trioxide plus H2O will give us sulfuric acid. So sulfur trioxide will give us sulfuric acid. If we take sulfur dioxide, it will give us sulfurous acid. Okay, sulfurous. This is sulfurous, this is sulfuric. Similarly, if you take CO2, metallic oxide, non-metallic oxide, acidic oxide with water, it will give you carbonic acid. Okay, and so on. So you have the reactions in the list and you can use the basic structure to learn the reactions quite easily. Now a very important and very interesting fact which I would like to make over here is that what happens when we take the non-metallic oxide nitrogen dioxide and react it with water. It's very interesting, the result is very interesting. Nitrogen dioxide when added to water gives two acids simultaneously. It produces two acids simultaneously. One is HNO2 and the other is HNO3. And to balance it, we have to give 2 over here. If you need a separate video for understanding how to balance equations, chemical equations, please reply in the group, in the comment section. Please reply, do you need or not. If you know how to balance equations, very good. If you want to understand a proper way of balancing equations, I would like to make a video for you. I am very keen to help you out. Okay, so please reply, please comment in the group. So the interesting thing about this reaction is that when NO2 reacts with water, it gives you two acids simultaneously. One is nitric and the other is nitrous. One is nitric and the other is nitrous. That is why NO2 is called a double acid anhydride. A double acid anhydride. And this anhydride is nothing but a word used in as a synonym for non-metallic oxides. Okay, acidic oxides. Acidic oxides are also known as acidic anhydrides. Okay, different names for the same thing, acidic oxides or acidic anhydride. So NO2 is known as double acidic anhydride or mixed anhydride. It is also known as mixed anhydride. Why? Because when it combines with water, when it reacts with water, it produces two acids simultaneously. One is nitric and the other is nitrous at the same time. Let us move ahead to the next method of preparation, that is by oxidation of non-metals. By oxidation of non-metals. The next method is by oxidation of non-metals. And I hope that all of you know what oxidation means. Oxidation means addition of oxygen. Addition of oxygen is oxidation. So the basic structure of this reaction is non-metal plus acid will give you an acid plus water plus an oxide. Sorry, I'm not having a space, I'm writing it properly. Non-metal plus acid will give you acid plus water plus oxide. This is the basic structure of the reactions which takes place, which undergo in this, under this heading, by oxidation of non-metals. So let us take an example. Non-metal sulfur, and we have to take concentrated nitric acid. Concentrated nitric, and you know what is the meaning of concentrated. Okay, you know that is the solution. The solution of this acid will contain more percentage, more amount of acid in comparison to water. So concentrated nitric acid HNO3, and when we react with sulfur, it will give us sulfuric acid H2SO4. You can see that this sulfur is being oxidized, oxygen is being added along with water plus the oxide of nitrogen. The oxide of nitrogen. Okay, the oxide of nitrogen, and you have to balance this to get the proper result. Similarly, if you take phosphorus and concentrated nitric acid, it will give you phosphoric acid H3PO4 along with water and nitrogen dioxide. Balanced. So you understood this reaction as well. You have to learn this reaction. So I recommend that you please just learn this structure. Learn this structure and write the reaction and try to balance afterwards. Because what happens when students, they try to learn the reaction, they get confused in numbering in this, they get confused to write these numbers properly, because it's very difficult. It's not easy, my dear students. It's not easy to write the numbers exactly. So if you know the basic structure, you can write it, you can recall the answer, you can recall the chemical reaction quite easily, and you can balance it afterwards. Now let us move towards the next method, that is by displacement. Okay, displacement is a type of a chemical reaction in which a highly reactive element displaces a less reactive element, okay, and so on. So in by displacement reaction, what do I mean? I mean that the structure is salt of a more volatile acid, salt of a more volatile acid plus less volatile acid. So you can see the difference between the the nature of the acid. One is more volatile and the other is less volatile. So one less volatile acid gives salt plus acid more volatile. Okay, volatile. So this is the structure. Salt of a salt, this is not an acid, salt of a more volatile acid plus less volatile acid will give you salt plus the acid which is more volatile. Now what does this term volatile means? Volatile means that evaporates easily. Okay, when you keep that acid in the open environment, it evaporates, it becomes starts to evaporate. That is the meaning of volatile. Let us take an example, the salt of a more volatile acid, NaCl. NaCl is a salt of a more volatile acid. And a less volatile acid is H2SO4. Definitely H2SO4 is a less volatile acid. That is why it is preferred in most of the cases over HNO3. HNO3 is a volatile acid. So it gives us acidic salt. The salt will be acidic in nature. Okay, acidic means the salt will contain an hydrogen atom, at least an hydrogen atom. So what happens? Displacement. This is a displacement reaction. Displacement reaction is how does it occur? Displacement reaction, how does it occur? These two portions of the compounds combine like this. So these two portions combine like this. So it gives us HCl. HCl is a volatile acid. Okay, so I am writing this under this slot. HCl, acid more volatile. HCl is a more volatile acid. And NaSO4, NaHSO4, because the salt will be an acidic salt. So NaHSO4, sodium bisulfate is the salt produced. I hope you understood the methods, the processes of preparing the acids. Alhamdulillah. So if you have doubt, please reply in the group. Inshallah, I will entertain all of your doubts, all of your questions.